Yo, what's up? Good morning. Good morning, everyone. Good morning, Derek. Let's see if we can close up the placement today. So yesterday was a little bit more of a experimental approach to the placement system. I tried to see if we could possibly make it work with purely the physics in Unity, but since we want it to be reactive, so we need to repositioning rigid bodies without having to wait for updates, late updates or fixed updates, I mean. As it turned out, we could probably make a few changes, but we would have to do so many changes that going a non-physical approach or relying only on raycasting is most likely the better option. So that's what we're going to do today. And let's see if I can draw some stuff here. So basically what we're going to do is we have an object, a 3D object. I don't know what. And we want to let's create this one ourselves instead. Real quick. Basically what we want to do is, given bounds of an object and given the current rotation of it, each placeable object is going to have a separate, a lot of them are going to have the similar setups, but like how much we can rotate an object. So for instance, let's take the stool for instance. If we place that one, we should only be able to place it with the sit part upwards. So the stool, for instance, will be able to, on the X and Z axis, it won't be able to rotate. It will only be able to rotate on the Y axis. But if we might have another object. I don't know what that would be from the top of my head. But we might have an object that can be rotated on Y and X. So when we start to place an object, the first thing we're going to do is we're going to rotate it to its default position or default rotation, and then it's up to the player to rotate it if he or she wants to, and he or she will only be able to rotate it by deltas. So the stool, maybe we will only allow it to rotate in 90 degrees around the y-axis, but some other item, I don't know, a pot with a plant, might be able to rotate 25 degrees each step. So we're going to take the object, we're going to get the bounds, and I'm talking about the bounds with the colliders. So we pretty much take all of the colliders, merge them into one bound, and that is the bound we're going to use to position it. And what we're going to do then is we are going to take let's go with green. Good morning, Harukanan. We're going to take... Oh, really? Fuck it. We're gonna take this point. We're gonna take this point. We're gonna take this point. And this point. And then we're gonna raycast downwards, basically. So we're gonna find where these hit the ground. I had a drawing like this in GIMP yesterday, but I actually like to draw in this software better. Might refine it a bit later on. We're gonna raycast downwards, and then we're gonna find, maybe this one should be green actually. And then we're gonna find the actual points. And these can be, we could actually get a case where we get something like this. So we're gonna find the actual points. So where can these points, where does these points end up on the plane we're trying to place them? And then when we have these 4 points, we're gonna try to fit a plane to them. And this is probably, like here I need to make a decision as well. When we place objects, we probably don't want them to be, if the character bumps into them later on, we probably don't want them to move around. It all depends. Probably depends on what surface we place them on. If we're inside the home, maybe, and we place furniture, then we probably don't want to be able to bump into them and displace them by bumping into them. But let's assume that we're outside in the garden, and this is where I want the objects to be more lively out here, so you wouldn't be able to place an apple and then not be able to move it around by bumping into it. So when we find this plane here, so 4 points in 3D space, at least 3 of the points are going to be in a plane. But we're always going to have a 4th point that maybe isn't in the plane, right? So then it's a question of, like, if we're placing it inside and the object we place isn't going to be physics-based when it's placed, it's going to be static, then we can just disable the rigid body. And then we minimize, then we create a plane which fits these 4 points with the minimum error, which means that part of this bounding box might appear below the ground or inside of another collider. As long as this object is not physics-based when it's placed, that's okay. But if we place objects outside, we're probably going to have to fit a plane here to these 4 points where none of the points intersects another collider. The first case, fitting a plane to 4 points with a minimum error, that's probably pretty straightforward. I can't do it on the top of my head, but I'm pretty sure we will find a solution we can just copy and paste pretty much. or implement with not much trouble. But finding a solution, so fitting a plane here where none of these points gets pushed down even further down might be a little bit of a bigger problem. So it's basically we want to fit a plane to these 4 points with a minimum error, but we want the minimum error only to be upwards, so positive. Maybe with that constraint it will be a bit easier. But apart from these 4 points, we also need to care about this full bounds. Like, we need to double check so that, because we might have a collider that goes like this. So we also need to make sure that, so it's pretty much 2, like it's a valid position to place it if we can fit a plane here that isn't rotated too much. We can take the normal of the plane later on and compare it with the rotation of this one. But it's also, we need to check for no other collider overlap. So let's see here. Okay. I'm getting extremely weird behavior here. Oh well. Okay, let's just not edit this one in here and do it here instead. This is not really true anymore. We're gonna do it like this, and then constraints. We can do it here. Um, Yo, what's up, Mr. Coder? I checked yesterday's video and noticed you're doing pick-up drop stuff now. Nice to see gameplay stuff. Yes, indeed. I think we're gonna do something like this. I wanna get placement in order. Want to have it working in a nice way, and then we're probably gonna add some sort of tent where we can place some objects, and with that we can probably do a nice day-night cycle and stuff like that. So yeah, we're gonna do game logic. We're gonna do some game logic stuff for a while now, I think. Okay, so let's worry about these let's get these 4 lower bounding box points. First of all, action, interaction, place. We have some placeholder boxes here. And here we pretty much just want to place these boxes at these points, and this is just for visual feedback during development right now. So we get the bounds from the entity and place them at min x z, min x max z, max x min z, and max x max z. What we noticed yesterday, though, is that we have this bounds here from entity. It only checks for colliders that are enabled and is not triggers. And in this case, since we're placing the item, we have actually disabled or converted most of them to triggers. So we need a get bounds method that takes some booleans, so we can decide ourselves if we want all colliders or only the enabled ones, and so on and so on. Mr. Coda, how long has it been since you moved on from graphics code on this stream? I don't know, it should be available on my YouTube. I try to place some description in my live streams. I don't think it's that... At the beginning of May, maybe. Yeah, I think we did applying tessellation up to somewhere in April. Then we did some terraforming. Then we did some rendering features because we had some problems. But I think we started doing some game logic, gameplay stuff in the middle of April, then went back to some graphics stuff, and now we're back at gameplay. So what we want is something like this. This was the last thing we implemented yesterday. So get collider bounds. We want to be able to send in is enabled, is non-trigger. So how do we do this check here? We can do for check only enabled, check only non-triggers, or check only non-triggers. Am I gonna have to do this? Let's do I don't know how much space we saved by doing this though, but maybe. But then we need to do it. Let's keep it like this. Let's see how long it becomes before we need figure out if we need to change line. Mr. Coder, game logic is, in my opinion, far more interesting than reinventing the wheel with graphics, etc. If you get my drift. We're probably gonna reinvent the wheel with some game logic as well. But I definitely I catch your drift, so to speak. So are we gonna have to do it like this? So check only enabled or enabled. So if this one is true, then this is false, and then we need to be enabled. If this one is false, then this one is true, and this is okay. And we want to do something similar here, don't we? And we're gonna have to change line. Something like this, I think, if my Boolean logic and default is gonna be only non-triggers and only enabled. Can we make these a little bit shorter? Non-enabled only. Yeah, whatever. And then we delete this one. We're gonna get some problems because we used onDraw gizmos. And this is where we're gonna ask for some other stuff. Enabled only, false and false, I think. Triggers, though, might be another question. Let's see here. Enable physics is trigger. Yeah, I don't know. This is probably going to be a future problem. Yeah, exactly. I wonder if we just want to do... It should work if we just do... I'm pretty sure. because trigger, we're probably gonna have a lot of items with colliders that are triggers only to drive behavior maybe and stuff like that. If we take a look at an entity like a creature, maybe it might have a, I don't know, if it's afraid, for instance, it might have a sphere collider around it that is a trigger to force some type of behavior. So disabling physics should never change how a collider works. Let's see if this works with everything we have. And occupy, get collider bounds. Okay. Now we should be able to get the 4 points. I hope. So we pick up, start placing. Do we have... Yes. We have our 3 cubes here. Okay, I get it. So we can see the colliders here, the bounds we're getting from it. It has a little bit of a weird rotation currently. This bound is... This one is wrong, I would say. But then again, we go X and Z. So it doesn't look that good to me. I wonder if it's because... Yeah, doing it like this works. But I can also see that... I find it a little bit weird that these aren't placed. I thought this bound would... We're gonna do this. Action, interaction, place. Let's add... Center and sides. What happened with this one? Yeah. Placement of these 4 visual points baffled me a little bit. Start placing. Yeah, this bounce is wrong. Don't we take rotation into account? In what world is these bounds? Okay. Don't we get... Okay, I don't think we get the top collider, do we? So I'm talking about this one. We should be seeing... We should be seeing a little bit of a bigger... Not enabled. Quet, what's up, what's up? Can you maybe snap the object's top part according to normals of the object facing upwards? Not entirely sure what you mean. What is with these bounds here? I have to double check this one for sure. We should be seeing way bigger bounds here, unless... Something could definitely be wrong here, but... Bounce, center, and size. Always twice as large as the... Okay, let's just double check this one if it's... collider in colliders. Get components in children. We do it in a wake. Should be okay in this case. Could it be... Yep. Where do we have it here? Okay. So, when we get the bounds of the colliders, they have to be enabled to properly be calculated. So if the bounds are enabled, and we'll rotate this one around, is kinematic is okay. So it's probably only setting it to kinematic is probably the only thing we want to do. I just wonder how much it messes up some other stuff. Here, placing it, we would get pretty weird points, but I'm probably okay with these. So if we place it like this, yeah, so this is probably worst case scenario. This is pretty damn rough. I know, like in this case, maybe we want to be able to place it in 45-degree turns instead of only having 90, 180. So if we go with this solution and allow for 45, then we're going to get our placement points. It's going to be here, 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 and here. So the question is, do we want to define custom placement points? Or do we want to try and clean this up? Because then when we check with collider overlap, we can probably do that per collider later on. But getting these 4 points, I'm thinking about the kinematic part as well. It should be okay. So this stool, for instance, would have 4 placement points. We're gonna define them with transforms for now, but we might optimize it later on. We don't want to have too many transforms. So we would do placement point, placement point, placement point, placement point, and then we would use those. But then that would mean we would have to define them for every object, and we take a look at this one. So shovels might actually be one of those objects that we could allow for placing by rotation here. This, I don't know. But we could also allow for rotation like this. Calculating the 4 placement points would be much easier in this case. Instead of, I guess we would have 1 placement point here, maybe 1 here, and then 1 here and 1 here. actually getting, so we're just using this to get the plane right. We want to get these 4 points and calculate the plane. We're not going to use these 4 points for overlap check. So these might actually be, yeah, we could probably go with these. Okay. But enable colliders, enable physics. Yeah, might need to rethink it here as well. Entities. Enable physics base, enable physics. I'm thinking about just doing this, honestly. Static entities, disabling physics here is disabling the colliders. Dynamic entities, disabling physics is just setting the rigid body to kinematic. Okay. Oh, yeah. The rigid body here. So this is the reason we want to disable colliders in some case. We'll rely on this quite a lot, actually. Can we do... I actually find that extremely weird. So, if we have an object with a rigid body and X colliders, if we make that rigid body kinematic, then the collider bounds don't recalculate. Yo, what's up, Jared Love? Find this very weird. but also good to know. So we have a set of colliders here. We have a rigid body which is kinematic right now. Although it's the disabling of them that screws with us. Okay, that makes much more sense, I reckon. That definitely makes more sense. Oops. But okay, yeah. I'm going in circles right now. But this means that, okay, so for apparel, for instance, when we put it on, we need to disable the colliders, because if we just do the rigid body kinematic, then the parent's rigid body will control them, it seems. And in that case, we get some weird behavior. How would we go about it here? I think we want to do entity, enable physics. We have enable colliders. We probably want to split these up. Yeah, we do. Enable colliders. We're gonna do it like this. Good morning, PG King. Do we really care about this one? Maybe. So enable colliders, enable rigid body. And then we're gonna get a hell of a lot of errors we need to fix. Let's see if this works. Interactable pickup, handle interaction, enable physics. Instead we're gonna do enable rigid body, false. Enable colliders, false. apparel. Interaction use. And then we have place here finally. So here we're gonna do enable rigid body. Enable rigid body. Something like that instead. And what the fuck, do we still disable? Oh, that is true. Colliders. They are still disabled because we pick up disables it. So and now we have some bounds we can play around with. Okay, good. And our 4 points are located at perfect positions. Okay. So the next thing we want to do is, so every placeable object should have a default Euler, angles. So we're going to start by rotating it by this. I thought we already did that. Maybe we don't. And then we're going to use these 4 points. We know that with this one, I think we will be okay. Action, interaction, place. Yeah, we don't use this anymore, but so what I want to do first is, or actually after we have disabled physics and stuff like that, then we want to do transform dot like this. And I'm gonna show one thing here. Okay, that's beautiful. So this is the default placement rotation we have on this one. Is it aligned with the world? It should be. Mr. Coder, so you're relying on a self-computed grid to get collisions. No, I think, like, I've been thinking about having a grid-based placement system, but I think we want to be a little bit more free than that. So the idea is, so when placing this item, we're gonna do some ray casting from these 4 points. We're probably gonna have to offset them upwards, so I'm thinking we're probably gonna do ray casting from the top bounds instead of the lower bounds. So we do ray casting downwards, find 4 points where we can on a placeable surface. Then we calculate a plane with the minimal error, and then we get the placement, position, and rotation. Mr. Code, your collision is all your code, not relying on anything Unity. No, like... depends on how you see it. Like, we're definitely gonna rely on Unity collisions when we calculate this, but we're not gonna do it by using non-kinematic rigid bodies, because we just get too much physics noise that destroys the placement procedure. If you want to see how that looks, you can check yesterday's VOD. We did some experimentation with trying to place non-kinematic rigid bodies, and it's just a little bit too messy. So we're gonna disable fixed update physics checks for this object, but we're gonna do physics ray casts and stuff like that to affect the transform of the object in question. I hope that answered your question somewhat, at least. So given these placement points that we calculate in real time from the bounding box, we're gonna calculate a plane, and it's actually that plane we're gonna place the object on, or place the object by, pretty much. So in this case right here, we would get a point here, a point here, a point roughly here, and a point here. And then we try and fit the plane to those 4 points. And then we make it so that and then we place that this object on that plane pretty much. But we also need to take into account the origin. The origin for this object is quite... it's weird. I like to have my origin, for some reason I like to have it center of mass. But if we take this bed, for instance, it has its origin here. We would calculate a plane here, so then when we place the object on that plane, we need to take this into account. So it's more... we calculate a plane from these 4. How would we take the origin into account? Yeah, we get an offset to origin. So this plane will have an origin, and we take that origin and then offset to the object's origin, and that's the offset we place it at. Yeah, I think it's pretty straightforward. The hardest part is definitely going to be fitting the plane to the 4 points, but I think it's okay. So we pretty much want to do this. Let's see. But I've always thought about this as I've always had objects, like placing objects on the ground when I've thought about this problem. I wonder if we want to place a painting, for instance, then we're gonna have a different direction for the where we want to check for the intersection points. That is true. Stool is pretty simple, this as well. But then again, so if we take this one, for instance, it would be nice to be able, we definitely want to be able to place it like this. We might actually want to be able to place it like this or this. But then I can imagine that we also want to be able to place it like this, maybe. I don't know. Maybe someone thinks this looks nice. So we have a dynamic place direction pretty much. For stool, it's pretty simple. We just want to check downwards. But I know. We always have a center point, I think. Yeah, we do. So let me show you. We're gonna have a point of reference pretty much. When we try to place this one here, our point of reference is wherever we have the mouse pointer. So this is the point of reference. This is what we want to stick it to. This one will be, if we're trying to place something on a wall, this point will be located on the wall, okay? So if we do depends on which points here as well. But like, we can take the normal of this reference point and then the opposite. That's the direction we want to place it in, right? So we have these 4 points. We have this point, reference point. We want to offset them in the direction of the reference point upwards, and then we want to raycast downwards, and that's where we find our place points, pretty much. In fact, do I want to bring in... And maybe we want to add some temporary stuff here. Maybe we do. Maybe we should. Fuck, it's time. Do we have? We have some placeholder prefabs we can play around with, maybe. Let's just bring them down a bit as well. Because we want to be able to place, not everything is going to be placeable on the ground. We also want to be able to place it. What do we have here? Oh yeah. Okay. So here we could probably, here we have two options. But we can test the system with this at least. Like either we show it like this and we just show it as unplaceable, or we actually rotate it so default rotation is in relation to the placement point. So i.e. in this case, if we hover here, we actually take this one and rotate it like this and show it as placeable, but as soon as we place it, it just drops to the ground, right? Yeah, I think we're gonna do something like that. Place and it drops like that. Okay. But yeah, I think it's all about, we get the point where we're currently pointing. We're gonna have to get the normal as well, which means that we're gonna have to extend the system a tiny bit. Because right now we just send down the object in question, the point in question, and yeah, the object and the point, but we also want to send the normal as well. So let's do that. Although I wonder. Point. Rake has hit point. That's just a vector 3. Rake has hit. I don't want to. We're gonna wait with that one a bit. I've been thinking about this, defining my own structure. So if we define point, that is position and normal. Very similar to transform though, but without. One sec. Inherits from component. Yeah, I want to have something like transform, but without most of the bells and whistles. I would want. Like, all of this is very good though. Parent, we don't care about parent. Would it be crazy to implement point? Hmm. Because what I'm thinking about is this. Let's see here. Input handler. As soon as we are hovering something, we invoke this game object focus event, pointer focus event. Here we just send a point. Here we send game object and a point. This is basically just a vector 3. I think I would like to be able to pass more information. Definitely the normal. Maybe even tangent. Which we have here. We have... Okay, so here we have normal at least. Which is pretty good. Raycast hit. I don't want to use raycast hit because, or maybe do I? But this is only rigid body, okay. Fuck it, let's do it for now. MISC. Realizable. Yeah. So then I want to do... We have system drawing point, game point. Actually, did we have any more? I don't want to have it as a class. If we have a rigid body, I don't care about that. If we don't hit anything, then it's just vectors 3, 0, yeah. It should be the same for this one. There we go. And then we work with this instead. I wonder how many places we use this. Highlighter. Yeah, we can play around with this as well. Vector 3 point. Variable entity. Action focus. This I'm pretty sure we want to change as well, but we'll see. Focus point. We change this one to position for now. Oops. Move placeable object. We get a new position here. Pointer focus event. We probably, like, I want to change that one as well. Visual pointer, update position. Nice. Move placeable object. And here finally we have what we want to use this one for. Eventually. Terraform, it's also quite good that we get point here instead. Or that we get the normal, that is. Okay. Okay. Okay, let's see if we can use this now. Yo, what's up, Bush? Good morning. I just want to see that everything works as it previously did. Now with this point instead. It should. Okay, beautiful. But now we have a little bit more information. Or actually, we have a normal now as well, which we previously didn't. But we're going to use this quite a lot in place, I think. Move placeable object. We get a point here now. Okay, this is good. So basically, fuck it, we're gonna do some weird rotation here again, I think so. So when we have in interactable place here, we have a default Euler angle. This one should be relative to the placement point, right? Or the placement point's normal. So if we have a point on the ground, you have the normal pointing up towards the sky, but if you have a normal on a wall like this, you can have the normal pointing in negative x or negative z or pretty much any direction. Oh, I think this is good. This is good. Because I just imagine like trying to place this stool on a stone maybe, which has a very uneven surface, right? Okay. I want to draw this actually. Let's see here. Can we do... Undraw gizmos. Oh, fuck, here we don't get the point. Okay. What did I do? And then we do here, I want to draw... Yeah, let's just see how this looks. Do we have pick up, start placing? Here we have sort of the correct normal, but this one I worry about. Really? Okay. But I'm a little bit worried about this normal. That definitely doesn't look like a normal to me. Or actually it does. Never mind. It's perfect. It is absolutely perfect. So if we try to place this one here, we would... Like, this is the default rotation, but we want to get the default rotation relative to the normal of the placement point. So this looks beautiful. Want to be able to disable this as well. That's why we need is trigger on those. Yeah, I don't know. Because when we place no, we don't want to be able to do this. Okay, let's try and fight with the rotation a bit then. So we want to change. I wonder here. If we do default rotation first, default rotation though is, yeah, we do default rotation. Default rotation is rotation relative to world transform, I think. Yeah, it is. I wonder if, yeah, I think we take this normal and then we take world up and we create a rotation that rotates from world up to this normal. And then we apply that rotation on the object in question after we have defaulted the rotation of it. We can try that. Which means that here we would rotate world up 90 degrees around, I don't know what it is, but world Z. Mm. So then again, let's just pack it into move placeable object. For now, we're actually gonna do it here. Yeah, maybe we do. Maybe it's this one that should. Yeah, it probably is. And then we do this, and then we do calculate transform. Where do we do that one? So I imagine it's something like this, but I'm as long as like as soon as this gets taken into account, I usually fail. But I'm thinking that we might want to do something like this. let's see here. Alignment rotation, and here we do Quaternion dot create a rotation from direction to direction, and here we take vector 3 dot up to point dot normal. So I imagine this is creates a rotation from world up to the normal, and then we do transform dot rotate alignment rotation, something like that. Space relative to, can't we rotate with oh yeah, rotation times alignment rotation. Could it be? Could it be? Pick up place. Looks pretty good. And then let's try with the wall. Fucking hell. We get some noise sometimes, but I mean, it's much better than the physics-based. Here. Oh, is that actually... No, it's not even... Wonder. We're gonna clean up that collider eventually anyway, but still... I thought it was between... No, it's just that we goes... Oh, what the hell? Why? I think when we create a quaternion rotation, we might want to add some more information. I will see. And then we have this. Okay, beautiful. And then of course we're gonna do some more this. It would be pretty nice if we could. We can render it with some specific material. We'll see. But this one bothers me. Let's see. How does it? Yeah, we go from 8 to 16. What the fuck? have something similar here. Mm-hmm. Mm-hmm. Do we... Oh, okay. I think we're not gonna do anything with this currently, but... So the height collider, which isn't really a height collider currently. Data value, macro type macro. Height collider point, vector 3 position, float 32, 3. That's 32 bits per value. Because I have this theory that we get some truncation of values somewhere. And I think this might be the culprit. I reckon data value. Value from value index UV. And what we do? Get index from UV, vector 2 in. So then we go this one, and then we go this one. Value int. Value multiplier, value normalized. Get pixel data float. That's big enough. Gonna have to look into that at a later point. Let's focus on this placement system now. I'm just gonna write it up. So I don't forget about it. Okay, so now we have the normal in place. And we rotate it based on the normal as well. Do I want to do the plane? Maybe. Yeah, let's try and get the 4 points and align it. Yo, what's up, DevSpiers? Thank you for the raid, appreciate it. And you too. What's up, Cooler SK? This object has a very thankful origin. So in this case, if we try to align it against a smooth surface like this, it works no problem. But if we try and align it here, it might actually work pretty good here as well. It actually does. Fuck, now when I think about it, fitting these 4 points to a plane with minimal error, we might have to do it anyway, but we could also only get the center point. We get the 4 lowest points, and then we get the center point. And put that one at the point in question. Maybe. But this case, for instance, I guess it depends on how we want it to work during gameplay. So maybe we would like to be able to place it like this, but then when we place it, it falls down, of course. Like the most... The only thing we want to avoid during placement is that we can be managed to, or that we can place something within colliders. That would suck. This is, together with the drop, this is actually a pretty good placement system already. Except for this, though, of course. But we would like to just stop it here, I guess. Wouldn't that be pretty nice? I like the idea that you allow for weird placements like this, which doesn't actually work. And we can't pick up that one. Can we pick up? Okay, let's add. Yeah, let's add placeable to some items that don't have a perfect origin. I guess we can start with this one. Actually, let's do this one. I wonder with interactable place as well, if that should be a component we add automatically to everything that can be picked up as well. Know about that, but okay, let's see. Placement constraints, default. We can just go with 0, 0, 0. So its default placement would be this. Yeah, let's see how this works. Yeah. So without... Yeah, we need to offset it here, because I guess this would be a pretty cool placement, and then we can rotate. Yeah. So basically we need to get the 4 bounding box points opposite of the placement normal. So in this case we would like to get these 4 bounding box points. If we have those 4 points, we get a center point, and then we offset the position of this one with center point minus origin maybe. You Optimist, what's up, what's up? I just found you on my feed. Good job, feed, I guess. Welcome, welcome. I wonder if, and maybe I overthought it with the aligning 4 points to a plane. Maybe this offsetting might just work for what we want it for. Let's take a look at bounds a bit, see what we have. Because now we want to get 4 bound points. We want to get the minimum points. The minimal point of the box, and this is in world space, right? I'm pretty sure. Or is it? Yeah, it is. I'm gonna assume that it is. So we pretty much want to get these. But I wonder, we can probably just do it as we have the normal. We can take the 2 strongest directions of the normal. Can we do it like that? So in this case, it would be positive Z. Or is it enough with... Yeah, we just take the points not the strongest in the... I wonder if that is enough. So here we have a normal that points in the positive Z. So for this shovel here, we take the bound points where we have... So we take minimum Z. And then we take all the points from minimum Z. So minimum Z, max X, max Y, max X, min Y, min X, max Y, and min X, min Y. That's pretty much it. Can we do this in any other way than... if else? So basically what it comes down to is that we have 2 points on the bounds. We have min and max, and we want to calculate 4 points from those 2 relative to the placement normal. That's about it. that is about it. We should be able to do it like this, I think. Interactable place. Do we have vector 3 max in Unity? Returns a vector that is made from the largest components of... Yeah, that's not what we want. But I don't even think we need the 4 points, actually. Can we just... We just want to calculate the size of the bounding box in the opposite direction of the placement normal. So we get this point. And then we have... We have bounds, we have size and extents. Extents, yeah, it's the extents we want. Wonder if we could do something like offset is equal to bounds dot x base dot entity dot get collider bounds dot extends scale by negative point dot normal, or is scale? Oh yeah. So we do it like this, and then offset dot scale point dot normal. Yo, what's up, Mercenary Mage? Hope you had a wonderful stream. Thank you for the raid, appreciate it. Have a good one, have a good one. For very basic items, I think this would be... This will do it. Probably. Let's see. Transform dot position We want to do this then. Or fuck, can we just do... We don't need to scale it, we just do plus equals to offset times point normal. I don't know. Oh, no, we need to scale it. Scale, but I wonder if we don't want negative here. Maybe. Let's try it, see what we get. Okay, we need to scale it in the other direction, but how does it look here? Maybe. Fucking hell. Oh. Yeah, we can't do it just like this. Ooh, we need to do... We need to take into account origin as well. So this is the offset, and we want to multiply it by... plus... what the fuck? I need to think about this one sec. We have a origin point, and we want to get... We want to calculate the origin point relative to bounce center before we offset it. So this one, for instance, has a... I mean, it has a perfect origin for placement. Which sucks a little bit in this case, but whatever. But here we have a... So the origin point, the world position point of this one relative to the origin point of the... Yeah, this one is in world position, this one is in world position. What if we just take those minus each other? That should be okay. Let's try it. Plus transform dot position minus bounds dot center. Maybe we need to do minus here, I don't know. Quicker to brute force than try to figure it out. That's definitely not what we want. And that looks to be a bigger problem than just an addition or a subtraction. Definitely. Okay, that's also one. Hmm. um, but this one, thanks to its origin point, we don't need to offset it at all, because the origin point is a perfect placement point. But for this one, we have the origin here. And we want to set want to offset this one like this in this case. Origin, origin, origin. Bounce, bounce, bounce. Can we just do... Do we want to make the bounding box center the deciding variable, or do we want to do the origin? Center of bounding box. Yeah, in this case we would get too big of an offset as well. Fuck. I don't know. We probably need to get this plane. This... that won't help us. Yeah, because when we have weird... like this bounding point... This one looks good. This one does not. Maybe the 4-point stuff isn't so bad after all. Or 1 point. 1 point is probably... okay, we can. I think we can simplify the problem to this. The problem explanation. Or description. We want to find... fuck, can we? No. Or maybe. Okay, it's pretty much like this. The description of the problem, as I see it right now, is that for the placeable object, we want to find the last point or the end point of the object in the direction of the inverted placement point. Pretty much. So this one, when we place this one, we have a placement point here. That's where the mouse is pointing. And given that normal, we want to offset the whole object. This one is a very simple example, but like that point in this case would be this point. So then we offset it with this distance. But finding this point is troublesome because, let's just drop that one here. The bounding, the collider bounding box, it so with a rotation like this, we would find this point, which is too far away. Then we get this offset. That's not good. I don't want to go through the individual colliders either. I don't think that's very good. So for this one, we have 3 colliders. It's not too bad. Maybe. Closest point on bounds. Closest point on the bounding box. If we had predefined placing points, it would be extremely easy. But then again, we don't know the placing points of the object being placed beforehand, because this one we might want to place it like this or this. It would be so nice if it was automatic. It would be even better if maybe while placing this object on this surface, it would automate to what do we have? This rotation roughly. Fuck, which makes me think placement points, defining placement points might not be such a bad idea. But in this case, the 4 points would help us quite a lot. So if we take, if we take the 4 corners here, project downwards, so we find 4 points on the surface, we take the middle point of those, and that's where we want the placement, I guess. Because even though we have the bounding box is quite enlarged this time around, if we took this one, this one, this one, and this one, project downwards, we would eventually find middle point somewhere here. How would that work for this one? So here we want to place it on this point. We have a normal pointing outwards. We take this one, this one, this one, and this one. Project them downwards, but what the hell happens here? We don't find anything and we're screwed. Ish. Or we find a very distorted point. We have we have a limit of how far we raycast. So we might end up here. So we get a point here, here, and 2 over here. The middle point is this one, and yeah, we're screwed. But we might have sweep test. Yeah. I do love sweep test. Then we get a raycast hit. Query interaction. Oh, beautiful. The impact point in world space, that's probably not where we wanna... So if we did a sweep test, let's see here. Yeah, the problem is that we would probably want to bring it out, do the sweep test, then we would get this point right here. And we choose that point. That's the point in world space. We have this one located here, so we can transform. We transform this point into its local space, and then we get the offset. I think we can get the offset. So we take the origin point into account. But push out, sweep test. That leads to a lot of problems because... But one sec. Yeah, we have direction, but nothing else. Mm-hmm. Like, just making this offset leads to a lot of problems. if we don't do an initial offset, we're gonna get... But what am I thinking here? If we do... There's all hits. No. But, what we could do is... Is this weird? Is this weird? Physics. Fuck. This is pretty cool. What the fuck? Okay, but we can't have compound colliders. That's unfortunate. Because this one is... Fucking hell, this one is nice. This is pretty cool. Ignores backface triangles and doesn't respect physics. Queries hit backfaces. Custom deep penetration. This function is useful to write custom deep penetration functions. That's pretty much spot on. Holy fuck, if we can use this one. Compute penetration. Oh, it's so good. But if one of these could be a rigid body, then it would be spot on. But we can probably make this work. I hope. Then again, we could brute force it by going through all of the colliders in our compound collider. Or we could probably... we can get the compound collider in question. If we just use the positions of it, so then we have this collider that is furthest away from the point in the opposite direction of this one. So we could be possibly filter the different colliders making up the compound collider. And then just do a check penetration with that one. A little bit... yeah, that would work in this case as well, I think. Depends on... yeah, it would. But then one have to be careful while building up these compound colliders. Okay, it's not exactly what we want. But can we use it? Can we do... Sweep test. Hmm. Your love, I finally got the animation to export properly. What a nightmare, yeah. Been there. But congrats. What was the problem? Doesn't respect physics course hit back faces. Your love, the NLA system was my problem. Yeah, the one we mentioned yesterday. Yeah, I know I've had my problems with that one as well. if we work with compute penetration here, even though we would get the collider, the relevant collider, that one would still probably result in something like this. If we can get the relevant collider, we could do a box cast to find when we're outside, but I don't know. Rotation of the box, this is pretty good. Yeah, I haven't really, to be honest with you, I don't really see the point or what the NLA system is for. Maybe it's useful for something. I just love it's for blending animations, but I don't need that. Okay. I guess I still can't let go of these 4 points here, but yeah, they are too... Okay, the original idea, if we can find the 4 points furthest away from the direction of the hit point, here it would still be this one or these 4. And then we create a plane out of those. We take the center point of the plane. If it was center point of the plane, we still need intersection, or do we? Maybe not. We take the 4 center. Oh, okay. Yeah, maybe we can do it like this. We get the 4 points making up the face of the bounding box furthest away from the point, or in the opposite direction of the place normal. Then we take the center point of those 4 and raycast from that one. Center point here. Or actually, we take that center point and then we just offset by that one. Could that work? I don't know. Gerald Love, would a cube cast work better? We have looked into it. I don't know. If we rotate this one, I will reset the rotation. Okay. Or okay. How would that look with this one? Maybe. Got this now. Let's see. Pick up, place. Place point is here. The problem is with this object, this is an object we don't need to offset because it has a perfect place point. So for this one, our place point is already calculated. But we definitely don't want to screw up with this one, or screw with this one. But if we take the origin here, we could raycast from where we place it, and then where we leave the bounding box, and we get that point, and that's how much we offset it with. How would that look for this one? This is placing point. Here we would offset it as well, which sucks. Because this one has a weird bounding box. Like the hardest part, or what we're trying to solve now, is that we would like to get this point, or calculate this point in some way. If this one was rotated like this, what point would we like to calculate then? Is it still... And then it's this point. The bounding box for this one works so well, I would say. The length of the sweep. Would love to do a sweep test, but only between two objects, two rigid bodies, I guess. Which I thought we would find in physics if we had access to something similar. Or this one, but limited to one direction. So I don't care about this one. Gerald, are these streams ever useful for you to use as a reference? I've referenced parts of streams to other people, but me myself haven't used it yet. But I imagine I will when I make some videos in the future. This is so fucking cool, this one. But if we could limit this one, it would be amazing. Gerald, I don't mean for content, I mean for troubleshooting. Ooh. I think I have checked one or two things. So went back to a video and checked. But not more than that, so not very useful, I guess. Compute deep penetration. Ah, this would be... I'm still wondering if we can use this in some way. Minimal translation. Passing position or rotation that is different from the currently set one doesn't have an effect of physically moving. Okay. So close to what I want. Yeah, the problem in this case, we would get this instead. Have to rely on rigid body. Where do we have it? It's the wrong direction as well. I find it weird if we could do this with layering as well. Or can we do some hacky stuff with this one? Couldn't we? I don't know how nice it is to instantiate a fake collider, but we could probably... Passing positional rotation that is different from currently set one doesn't have any effect of physically moving any colliders, thus has no side effects on the scene. So we could take the collider and reposition it. Because what I mean, like if we had a temporary box collider here that were extremely big in Z and yeah, in the other directions as opposed to this one, so we pretty much force it to depenetrate in this direction. That's also, it feels a little bit weird, but maybe. Why not? But it has to exist a better way to do it. It's pretty much how much do we need to move it in the direction of the place point normal for the object to not collide anymore. Deep penetration in one direction, pretty much. Can we do deep penetration? Okay. Calculate the overlap stall for each plane. Multiple iterations. Yeah, we're gonna have problems like this eventually as well. It's a pretty complicated problem to say the least. But we just want to take the worst case scenario and move it away. Or we want to move it away from this one, and then we check if it isn't colliding with anything, then we can place it otherwise. So imagine if we had a object here, then we would still get a collision here. We wouldn't be able to place it. Fuck, solving this problem. Could we do... take this point, offset it in the place point position, maybe to about here. Then we do a ray cast, but we try and find this specific only this object. So we want to do raycast against one rigid body. We would probably find this point. If this one was rotated like this, yeah, then we would find this point. That's wrong. I want to find this point. We basically want to... Okay, so if we offset here and then we find the closest point on this one to that one. Okay. Do we have that in rigid body, or are we gonna have to go through all the colliders? Rigid body, closest point on bounds. Is not what I want. And then we have this one again. Offset to here. We'll probably get this one. A sweep test. A sweep test, but just checking this collider would be fucking amazing. Then we would have it right. Bam. We get a collision. Sweep test with this one. Get a collision. We have a distance rather. Nah, sweep test is definitely the answer. Are we gonna have to temporarily layer switch? I worry about that though. Not what I want. Yeah. I wonder if we can do this. But is this weird? Because then we have the placement object. We have the object we're trying to place. We switch layers. We do a sweep test. We get the distance then. We get the distance. And then we're done. And then we switch back layers. Is that weird? Feels a little bit weird. But it would be fucking amazing. But what would that entail? We need to look into that one, but not right now. Would it be weird? And then you have a... So they only collide with each other. Yeah, I mean, we can try it. Let's see if I have the time to fully try it today, but we can... no idea what I want to call it. Placement layer. Makes it quite specific. I'm wondering if we want to have this... want to use it for other stuff as well. Let's call it placement layer. Rotate it and stuff. But we don't have the object we want to collide with. We're gonna have to... we can get it pretty easily, I think. Instead of listening on... go to... Instead of listening to... pointer focus event, we listen to something else. We listen to... game object focus event. Dear love, how do you have so many subs but not so many viewers? All I can think of, you don't have a camera set up. Possibly. It could also be that most of the subs do it for the shorts or the long form videos. Not everybody have time to watch live streams all day, you know? We'll see how I do after the summer. Might look into getting a camera. I know that for some reason people do prefer that. Okay, let's try this one. I don't know if I have time today to fully test this one. I need to run real soon. So I might leave on a little bit of a cliffhanger, but we will see. So then that would be here. We're gonna do experiment. We do layer mask, or actually we want to do place surface object dot layer. It's an integer. Int layer. We're gonna have to do it like this: int place surface object previous or layer is equal to and then we do what did I call it? Placement layer. Yeah, place surface object dot layer. And your love, yeah, except I see channels with 300 subs getting 50 viewers. I have no idea, man. Are we still talking software streams or something else? Okay, we do this, and then I want to do we have rigid body here? Let's do it like this. We can get it in a cleaner way eventually. And then we want to do sweep test. Or first we want to do minus equals point normal times, I don't know, 10. We can start with 10. I just want to see if this works. And then we do RB raycast hit. And then we do RB sweep test. Direction is point dot normal. And then hit. With a little bit of an out before it. And then when we have this, actually we can do if Then we do from the race origin to the impact point. So origin in this is probably the origin of the object. So I guess we can do transform dot position plus equals to point normal. Sweep test we want to do in the negative direction here. Do we want to do it in... No, here we just want to do it plus, but here we want to do negative. Times hit dot distance. And then we can finalize this by doing place surface object layer. Fuck, I worry about this one, I do. Well, let's see what we have. Gerald Love, they do visual scripting with assets and camera. It might be more visually appealing. Are you sure they only have 300 subs? That's extremely impressive. Could be bought viewers. You never know. Okay, let's see how weird this is. Okay. Okay. I think this is... Do we have some extra offset here, actually? But I do definitely think that a camera plays a big part. Yeah, we get an offset by normal here as well. Other than that, we're fine. And the flickering. If we can get rid of the flickering and this little extra offset, then we're golden, I guess. Although I wonder about this one. Looks extremely good. Except for the flickering, of course. But then it seems like our offset, it grows... Oh, our normal here is extremely big, I see. Why? Love, you're going to be this for another year or 5, so yeah, 5 is, that's probably in the ballparks, I would say. The flickering, I'm wondering if... Oh, I might know what's happening. But actually, I think we can refine this and get a pretty good placement system. I wonder, though... Yeah, it would work for this one as well, I think. Yeah, it would. We just need to refine it a bit. I wonder, the flickering is very interesting. I think it could have to do... I wonder if it could have to do... hit distance. No, it's definitely this one we want to use. Derek, it's extremely important that when the table is placed there is no wobble, 100%. And if we can manage, like, we don't want any difference between placing, like, the preview where the table is placed and where it's actually placed. So we want to minimize that final rigid or physics noise as well. But yeah, I think we're gonna have to refine this one tomorrow. I'm very hopeful that this sweep test is exactly what we need. I think it is. I think we can close this tomorrow. And then we have a pretty nice place solution in place. No pun intended. And then we can move on to some other game logic related stuff. But yeah, we'll see tomorrow, because I gotta run. Yeah, thank you for watching, everybody. I appreciate it. Yeah, we're gonna close this off tomorrow, Derek. I'm 100% sure. I'm gonna show that it's not a skill issue as well, Gerald Love. You will see. You will see. Thank you so much for watching, everybody. Have a great rest of the day. Peace.